students, I am this is a square product. If we take two vectors AB, applied the vector element theta, and we take a perpendicular on the vector A of the vector B. Then the base will take the collinear of the two vectors, projection of B vector on the vector A. Then we can find out the square product. So if A vector dot B vector is equal to A vector modulus of A vector mod of B vector is equal to cos theta. Since the B vector is projected vector is mod of B vector cos theta, this will be A vector dot B vector. Here when they are parallel or collinear, so two vectors be on square under square product be parallel or collinear when theta is equal to 0 degree or cos theta is equal to 1. Then the condition will be A vector dot B vector is equal to A vector mod of A vector mod of B vector. So if they are equal with this condition, then the two vectors are collinear or parallel. Now, how we find out the angle between the angle used in applied in these two vectors? So here cos theta will be A vector dot B vector mod of A vector dot mod of B vector. So theta will be cos inverse A vector dot B vector by mod of A vector dot mod of B vector. So in this way we can find out the angle of between two vectors A vector and B vector, and when they are perpendicular to each other, so two vectors under square product will be perpendicular if theta is equal to pi by 2 or cos theta is equal to 0. Then the two vectors dot will be 0. Then under this condition, if two vectors satisfy this condition, then they are perpendicular to each other. Here, code number, condition that under square product two vectors square product is commutative. The dot product square product is commutative. How we can prove this? That a vector dot b vector, we are taking a vector is equal to x1I plus y1I j plus z1k, and b vector is x2I plus y2j plus z2k. So when we use the dot product between these two product vectors, they will be x1 x2 plus y1 y2 plus z1 z2. And if we find out b vector dot a vector, this will be again x2 x1 plus y2 y1 plus z2 z1. So we can look this that these two vector the two square products are equal. So this square product maintains commutative law or holds commutative law. A vector dot b vector equal to b vector dot a vector. Now I have discussed this vector product also, that vector product will be a vector cross vector, or vector product will be a vector cross b vector will be a mod of a vector mod of b vector sin theta, and a unit vector works on the direction perpendicular to the plane where the two vectors is applied. The unit vector works perpendicular to this plane. So n cap is the unit vector which shows the direction of the two vector applied on a plane which is perpendicular to this plane. So their condition of to be parallel is a vector plus b vector must be equal to 0, then they are parallel or collinear, and they are perpendicular if the unit vector is equal to a vector cross b vector by a mod of a vector dot mod of b vector multiply mod of b vector, then the vectors are perpendicular. But commutative law does not hold in case of vector product, since in case of a vector cross b vector we will have such like of form. In case of a vector cross b vector we will have I j k x1 y1 z1 x2 y2 z2. So this will be y1 z2 minus z1 y2 I plus minus x1 z2 x1 z2 minus z1 x2 j plus x1 y2 minus x2 y1 k. So this will be a vector plus b vector, and what will be b vector plus a vector? So this will be I j k x2 y2 z2 x1 y1 z1. So this will be y2 z1 minus z2 y1 I plus minus x2 z1 minus z2 x1 j plus x2 y1 minus x1 y2 k. If we rearrange this will be this is y1 z1 z2 z1 y2. So here we can look this is just we have to take a negative sign to arrange this. Here we have to take a negative sign. Here x1 z2 z1 x2. So z1 x2 z2 x1. Here also we have to take a negative sign to just make it both equal. And here x2 y1 x1 y2 x2 y1 x1 y2. So again we have to take a negative side here to make both them equal. So we can write down that a vector plus b vector is equal to minus b vector plus a vector. So here commutative law does not hold. It proves that commutative law does not hold in case of product, but in case of square product, commutative law holds. Distributive law holds for square product. For vector product, distributive law holds. So the distributive law holds for both square product and vector product. So how we can show that? So as left vector product, I am showing for cross vector. I have shown earlier also for case of square product. So I am showing for cross vector product now. So a vector cross b vector plus c vector is equal to a vector cross b vector plus a vector cross c vector. So how we can prove this? That the left distributive law holds. Here if we take b plus c vector 8, we say a vector is x1 I y1 j z2 z1 k. B vector is x2 I plus y2 j plus z2k c vector is equal to x3i plus y3j plus z3k. So b vector plus c vector will be x2 plus x3 I plus y1 plus y2 j plus z1 plus z2 k. Now if we cross, then a cross b vector plus c vector, this will be I j k. Here we can write down a vector is x1 y1 z1, and here it will be x2 x3 y2 plus y3 plus z2 plus z3. So by the properties of determinant, if we further break down it, this will from this we will get I j k x1 y1 z1 x2 y2 z2, which is equal to a vector cross b vector, and plus I j k x1 y1 z1 x3 y3 z3. This will be a cross c. We can look this that left distributive law holds for vector product. In this way, we can prove that right distributive law also holds for vector product.